Okay, so now we've done some actual distances and looking at using trig that way, but what happens if we have simple harmonic motion? This is where you have a point that moves on a number line, and if it's got a directed distance d from the origin, so like let's say we have a mass on a spring and it bounces, it creates simple harmonic motion. And these are the two equations that you will be given, you do not need to memorize these, that you would use. A and omega, that's that W, are real numbers, and the W is greater than 0. The motion has a frequency of omega over 2 pi, which is the number of oscillations per time. Now this is a sinusoidal, and the A stands for amplitude, and the period is just 2 pi over omega, which in other cases has been our B value. So if you want to see how the unit circle works, you can go to page 430, but we're not going to cover it here. In a mechanical linkage, like the one shown in figure 4.94, a wheel with an 8 centimeter radius turns with an angular velocity of 8 pi radians. What is the frequency of the piston? So what we have here is we say that we have D equals, and they told us it's a cosine. So what we're going to do, mechanical linkage shown, we have a radius of 8, so that's my A equals 8. And if I look at cosine and it says the omega, the angular velocity is 8 pi t. All right, now the frequency. Frequency is omega over 2 pi. So if I take 8 pi over 2 pi, I get 4. So it makes 4 pi cycles per second. What's the distance from the starting point when t equals 0, exactly 3.45 seconds after starting? So we're going to find it at 0. We're going to find it at 3.45. All right, so what we're going to do here is we're going to take 8 cosine of 8 pi times 0, which is 8 times the cosine of 0. And if you remember on your unit circle, the cosine of 0 is 1, so we have 8. Here, you're going to take this and you're going to put 8 cosine 8 pi times 3.45, plug it in your calculator, and you get 2.47 centimeters. So if they started off at 8 and they're now at 2.47, you're looking at a total distance. So you want 8 minus 2.47, which is 5.53 centimeters. That is the answer for here. Okay? Now let's calculate harmonic motion. A mass is going up and down on the bottom of a spring. We're assuming perfect elasticity. That means it doesn't lose any energy due to friction or air resistance, and it's modeled as a harmonic motion. If the weight is displaced a maximum of 5 centimeters, find the modeling equation if it takes 2 seconds to complete one cycle. So we've got, it's hooked to this, we have a spring, and here's my weight. So what I'm going to do is I'm going to draw a number line here, and we're going to call this 0. And it says if the weight is displaced a maximum of 5 centimeters, so it goes 5 centimeters up, and it goes 5 centimeters down. All right, so now what we're going to do, this is when it is completely, and this really should be here. It's when it's completely up against the post, and this is when it's completely stretched out. So now we have D equals A sine WT. We're starting at 0, so we're using cosine. Now the frequency is omega over 2W. And they told us that that's 1 cycle every 2 seconds. Okay, so let's cross multiply. 2 pi equals 2 omega. and so omega equals pi. Now they told us the maximum displacement is 5. So our final equation is 5 sine pi t. And then you'll be able to know where the distance is no matter what time you are at.